Hello, my name is Santiago Moreno, and welcome to 7.1 Modeling with Differential Equations. Today we're going to be talking about basically modeling differential equations as the title suggests. But what exactly is that? How do we see that? Well, let's just do it here. So let's see, directly proportional. We have to understand proportions, right, for this. So directly proportional, what does that mean? We say that something is proportional. It means that when A increases, then B also increases. So A is equal to B. Let's see. Then A, sorry, should we do that? Then A is equal to B. But there also is a K. There has to be a constant because A is equal to B. So when one increases, the other increases by the same amount. But it doesn't necessarily have to. It increases by the same amount. So if A increases by 1, then B also increases by 1. However, there is also a K, which is just any constant. It could be 1, it could be 2, it could be any number, but it is a number in front of B to because we don't know how much it's going to be increasing by. So when one increases, the other also increases, and it increases kind of by like a a the same amount every time. So this would give you this proportional graph would give you kind of like an xy graph, a y an x a y is equal to x graph, y is equal to mx graph. It'd be this type of graph, a slope, very simple slope, a 1x slope. However, inverse proportional is proportional to the reciprocal. So that means that if A is inversely proportional to B, then A is equal to B. Let's write that down since they're a relationship where K is a constant. Inverse proportional means that when one increases, the other is decreasing. And it's not a negative. Inverse, it's like an inverse. So when we're doing inverses in our in our graphs, it's kind of like something divided by the variable, right? And since k is the constant, it remains the same, and b is the variable. We would do k over b. A is equal to k over b. That would give you an inverse graph. It would give you an inverse graph. So let's just try to do an example to try to understand what this means. The rate of change of y with respect to x is proportional to the product of t and the rate of change of w with respect to x. So let's just write it step by step. The rate of change of y with respect to x is dy dx. And this is proportional, so it's a relationship, so it's equal to. It's proportional. You can either put equal to, or you can, there's also a sign. It looks a little like this. We need to say it's proportional. I think that's actually inverse proportional, but you could also put equal sign. Is proportional to the product of t, so we're going to put t times the rate of change of w with respect to x, so dw dx, and that would be everything that in the problem. But we also can't forget that it is proportional from the very first rule that we see, the very first rule that we see here, directly proportional. If a is proportional to b, or if this a is proportional to this b, then it's a times b. Then a is equal to b is equal to k, so this times k, k times b. Because if this is a, if this is equal to a, this is equal to b, then we have to multiply k here. So dy dx equals to k t dw dx, and that's the answer. That's how you would describe the proportional relationship. But that's basically the basics that you need for 7.1, modeling with differential equations. And yeah, we'll see you in the next one.